The NoBugs antivirus software company tests computers for viruses. Viruses are present on 1% of all computers. This software is 97% accurate. 1%, that's important. Let's complete this table pretending we're starting with 80,000. Okay, so if we know our total is 80,000. Alright, and as discussed, you always want to complete this side first. If you don't have your totals, you can't really do anything else. So, we know 1%. So 1% of the total is how many have the virus, and that is 800. So 800 has the virus. Now, if we started with 80,000 and 800 of them have the virus, then 79,200 of them don't have the virus. And now we have our totals. So now we look at the accuracy rate. And if your computer has a virus, we expect it to test positive. So this is where the 97% rate will come in. So I'm going to take 97% of my 800 computers who have a virus, and that tells me that 776 of them will test positive. And if I had 800 and 776 of them tested positive, that means 24 of them tested negative. Similarly, if your computer doesn't have a virus, we expect it to test negative. So 97% accuracy of the 79,200, that means 76,824 will test negative. Oops, wrong color, blue. 76,824. And if we started with 79,200 and 76,824 tested negative, that means 2,376 of them, 2,736, will test positive. Now we go ahead and add our columns, and so a total of 3,152 will test positive, 76,848 will test negative. And if we add those two together, we will get 80,000. Okay, so let's use this table to answer some questions. A little more nicely drawn right there. What is the probability that a computer tests positive for a virus? So we're talking about all computers, probability they test positive. Well, 3,152 will test positive out of the total of 80,000. So the probability that a computer tests positive is 0.0394. Or you could write that as a percent, 3.94% chance. Okay. What is the probability a computer which tested positive? So now we're only looking at those that tested positive. What's the probability it doesn't have a virus? Well, that's this number. So we're looking at those that don't have the virus over all of those that tested positive. Because which tested positive, we only care about that group. So 0.754. There's a 75.4% chance that if a computer tests positive for a virus, it really doesn't have one. This is called a false positive because you had a positive test, but it's wrong. Letter C. If a computer tests negative, so now we're only looking here, so my denominator is going to be the total of 76,848. What's the probability it does not have a virus? Well, here's the knots, 76,824. And that gives me a 0.9997. So 99.97% chance that if your computer says it doesn't have a virus, then it really doesn't. And the last question, what is the probability that a computer which tests negative, okay, so again my denominator, 76,848, which if it tests negative, probability that it actually has a virus, 24. This is the complement of the one we just completed, 0.0003, a 0.03% chance. This is called a false negative because you tested negative, but it was wrong.